Section 3, Video 3, Factoring. Now let's remember something important here, that factoring and foiling are opposite operations. Factoring creates parentheses. Foiling gets rid of parentheses. So if you look at this example, if we were to foil, and they do, that's foiling. And notice that we got rid of parentheses. If we go the other direction, which is actually straight to that, that would be considered factored, where we create parentheses. Guess and check or trial and error uses this table to help you factor. And if you look above, and I'm going to rewrite this example right here as p squared plus p, and it should be minus 20. If you look at that, in the trinomial, you have a plus minus. And over here, this is the trinomial part. And you have a plus minus, which takes you right here. Over here is the factored form, and it tells you what is in the parentheses. And based on what we had in the trinomial, it says you should have a minus plus. Well, in our answer that's factored, we have a plus minus, and that's okay. All these do right here is tell you that they have to be different. Order doesn't matter. So let's try an example. Now there's a different way of doing it besides just guess and check, and that is something we learned in Algebra 1, and that is to say, to break down the question, say, you know what, we're factoring this. We're looking for two numbers that have a product of this, which is 21, and a sum of this, which is negative 10. What are factors of 21 that has a sum of 10? That would be 7 and 3. It has to be a negative 10, so we would write negative 7 and negative 3. And again, we would put t first. So that's factored using this method. Okay, now notice, let's check it. We had a minus plus, which is right here in the trinomial form. Did we get a minus minus in factored form? Yes, we did. So it works. So let's try the next one here. Here we have two terms. It's a binomial, so we say it's a difference of two squares. Yes, it is. But we should also always look to see if we can simplify the question first, which means, yes, they do have something in common. Take it out first. And what you'll notice is we still end up with a difference of two squares. So 4m squared rooted is 2m. Square root of 25 is 5. And they have to be different signs. Now, that is the proper way to do it. If you were to just take it and approach it like a difference of two squares from the beginning, you could do it. Not a problem. But notice that both binomials can be simplified by taking a 2 away from each one. So we have some added steps to that. So you would still end up with this question, but you'd have some extra steps, and you might forget that had you not done it this way first. So again, always recommend to take something out first and see if we can simplify the problem. Here we have two numbers that we can square root, but because it is plus, we are done. We can root each number, but because it's plus, it is not considered a difference of two squares. And if you look at it then and say, well, is there at least a greatest common factor we can take out? And no, we cannot, so we're done. And the last one here, notice it's two terms again. What do they have in common? Well, we can factor out a 2, and we get 9 minus 25n squared, which is a difference of two squares. What makes this unique is the variables on the second term, which the nice news is it doesn't matter. We just got to write them first or second appropriately, and that's what we end up with. But notice again, first term rooted goes first in each one, second term rooted goes second in each one. And this ends Section 3, Video 3.